Hello world, welcome to my next tutorial solving problems with programming. This tutorial is about the WSQ13 SciLab, and I just want to show you how this software works. And what we're going to do is to read the tasks. That is, SciLab is a great tool that I believe you will find very useful during the rest of your degree programs and beyond. The motivation here is simply to introduce you to the tool. SciLab is open source software and runs on Linux, Mac, and Windows. So we need to download the latest version at this page, which I did. So I think it's very easy to download. I put here and you start downloading after you give some information. So what we're going to do is to play with this software. Please follow the tutorial available on the website on the documentation. Here's the direct link to the tutorial. This is page for civil download also. Do not panic, there are 33%, but it will not take you too long to go through it. So is this one. This PDF tells about how is control this system. And I just want to tell you about SciLab. SciLab is a software that you can analyze any kind of systems that are mathematical, or maybe a system of the universe that you want to make it countable as mathematical. For example, the physical systems of any system of the universe. For example, this one that is maze, a maze and a resistance and a system where it follows certain functions that you need to know what will be the behavior of this entire system, and you want to see it like equations, and this software helps you to analyze this kind of mathematical system into graphics and determine how will you do based on the behavior of this kind of systems. SciLab is a program that is common like in Matlab. As you can see, is this one. This is Matlab. This is the same as SciLab, and I'm going to show you how it works. So let's go to the basics. This is the environment of SciLab. You have your files. You have your command history that it tells about the commands of what you, or the history of what commands have you written here, and this is the variables that you have declared. For example, I can say a equals 3, and you can say 3, and there you go. You can see a, and the typical variable that for default is double, and this is 3. And if I put b equals 4, okay, b equals 4, there you go, b equals 4, there you go. I can say c equals a plus b, that will be 7, there you go. I can put, for example, just the number 5, and it says here and stands for the answer. Or if you can put it this way, and you can say c equals a plus b, and you can put semicolon in order to not show to the user the value c, and then you go to not show it, and you can say c squared, no, c times c, that will be 49. That will be 7 square. And you can, for example, you can delete this with still C. that is stands for delay all. For all delay of this kind, then I'm going to show you the first operations. That will be this one. That will be in the PDF. Is the same. So you can say 2 plus 2. That will be answer 4. That will be the answer 4. Or you can say 2 plus 2 semicolon, and you don't get an answer, but it still makes the operation. Then you have you can say the value like a calculator of this entire this kind of software. You can say sin of 3 and give you the value of sin in 3. That will be answered this, but it gives you in radian. Then you can see also cos 3. There you go, tan. Okay, and CLC. What else? You need to. You can put the same operations of mathematics, like a square root, like we say, what we see before, and this okay. Well, this software helps me in the part of no, I don't have to write the semicolon. I just go enter and I go the operation, because they answer me as an answer. So I think it's very helpful rather than the C++. So it's the same instruction as SQRT, that stands for the square root of 16. That would be 4, and it tells with a point. Then I can do other things like log. Also is a calculator. Log, it will be like log 10 base 10 of 3. There you go. Or log 3. There you go. Now it will be base A. That's why it doesn't appear to be. So you need to say the base. Okay. Okay. Then I can do absolute value apps minus 3. There you go. It's a calculator. But this is the basic operations. This software can do a lot more than I'm going to show in this video. I'm going to show this the basics. So I can say expon a power. That will be 1, right? Yeah. I can delete CLC. Remember. What else? I can. Okay, I can make constants like pi. You need to put the percentage before a pi. This is the difference between this and Matlab. In Matlab, you need to put it in front of it. So you need to put like E, for example, and there you go. You have the constants. What else? This is later. It can be SciLab can manage imagining numbers like I, that it will be square root of -1. For example, square root of -1. That will be I. There you go. uh, of percentage e is the same. Then where else? You can say that you can make variables, assign variables, like you say, to the constant numbers. X equals to the value of pi. That will be 3 point, the value pi. Then you can, there are some commands that you can use for this kind of value. For example, I guess this is, I can say, format rat. This is not in SciLab. Well, you can say, for example, long rat. Oh, no, so this is not in this kind of software. It's a little similar. Then what I'm going to show you is okay. In this one you can make graphs. Let me show you. Okay, I can say x equals to 0 with a range of pi over 100 from 0 to pi 100, and the final of the length 2 times the number pi. And I can say then, I can say g equals to sen of x and I guess I have a little problem. I have undefined, that's because I didn't put the percentage. There you go. And it showed me all the values. I can say, for example, CLT, and if I don't want to show this, I can just put semicolon, and there you go. And then I can say y equals to sin of x. And again, I can use, and I can say plot in order to make a graph, x and y. There you go. There you go, the sine function. From this to this, and I say the limits from here to here with the x range. That will be this one, from p to 100 to 2p to pi. Then also I have the cos. I can say e equals to cos, to the function of cos. There you go. I can play. I can put it all together. Then I can say j equals to tank. Tank. And then I can say plot now. There you go. And also the other ones, no? Sec. Well, I guess you get the idea, no? Oh yeah, I forgot plot. That will be the same because of the say domain. But yeah, I like the blue. What else? I can have, well, I can have a lot of graphics. I can have, I don't want to make this video take so long, but well, I'm going to show you. This is the commands. I can say A equals to Mexico. I'm going to delete. I can say A as a string, Mexico, and there you go. With this little comma, then I can say I can make it to lower. Well, I can say just when I can say length out, the length of the string, like in C++. That will be A. There you go. Is 6. That will be 3 and 3. I can say then also. I can say I can take another variable and make it uppercases. H equals upper A. Oh, I think with this function is not. Yeah. Well, I can make the length. For example, I can make operation of a math operation, like I want to show you this one. I can say like I said before, I can say A equals to pi squared pi 4 to the square. Okay. I can say pi times 4 squared. That will be the area of circumference with a radius of 4. Okay, there you go. Yeah, for that, in this one you need to add this. There you go, 15 unit squares. Then what else? You can play with that. I want to show you this one, the poly. Okay. I can make equations, polynomials of this form, x times 1 with an array. I can do arrays of vectors in SciLab, and I can say poly 1 equals to this array 1 times 1. That will be the size of each array. There will be 1 1. It will be this one. This is the x. This is the 1, and I can say I can say I can have the roots. Okay. I can say row equals to roots of poly1 that will be minus 1. There you go. It will be x times no, x plus 1 equals to 0, therefore x equals to minus 1. It can give you the polynomial of the other. And I can do also multiplication. I can say poly2 equals to x x minus 2. Instead of writing, for example, x minus 2, I can say 1 minus 2. There you go, and I can say com in order to multiply them. Poly 1, then poly 2. There you go, it will be x squared minus x minus 2, no? Maybe you do the mathematical operation. And then what else? You can... It's a very useful software. I can... okay. I guess, for example, I can make this polynomial. I can say, for example, poly3. I'm going to delete poly3 equals to, I'm going to write this function. This function for 2 minus 3. Okay. For 2 minus 3, you know? There you go. Then I'm going to make polyball, and then in polyball, polyball, the name of the variable, okay, poly3, and assign, for example, to in this case doesn't appear. Well, I can say some commands are repeated, like in this. Okay, I can have also the roots. I can say row again and roots of poly3. I need to search the other one. There you go. This is the roots of this polynomial. That will be the solutions. And this one I can give me the multiplication. That will be this one. I can do the comp that we did before. Okay, you can do this one, the comp. I think poly there. I don't know if this is going to work, but I'm going to play with it. Poly there. Okay. Poly1 equals to, I'm going to write again 1, 1, well, 1 minus 1. Then I'm going to do poly there. I'm going to know if I can do the derivative poly there. poly1, poly1. Yeah, I need to here in Kemba. Well, I can have the roots of the poly. That will be one. Row equals to roots. Yeah, it will be one. For example, I can do. Well, I need to. You can do the same operation as like Matlab with these commands that Canvaware provide me. You can use also the if, the else. You can use loops. The plot that we saw before, I can save, for example, I can make other types of graphs. Okay. X equals to an array that will be 1, 2, 3, 4, 5, and I can say there you go, and I can say pi x. There you go. So this is the command, the basic commands. I'm going to search. I'm going to post all the more commands on my blog, so check it out. So thanks for watching, and I will see you next time. No, yeah, I have a lot of things. Well, there you go.